Hi, everybody. This is Dr. Nigro with a Chemistry Notes screencast. This is the final screencast in the series focused on our Introduction to Chemistry unit. And this one will be dealing with density. We'll talk a little bit about what density is, and then we'll do some practice problems that involve the density formula. All right, so let's start with the definition for density. So the definition, basically, density is the amount of matter, which is represented by the mass of that matter in a particular space, which is basically its volume. So it's the amount of matter in a particular volume. That's going to tell us the density. All right, so here I have three beakers. Each one contains a sample, right? And each of these represents a different state of matter. So the first thing we're going to do is label each state. All right, well, remember, a solid is always going to have the particles packed most closely together. So there's very little freedom of movement and they're all in tight, so not a lot of empty space. Whereas the liquids, a little bit more space is present between the particles, so they have a little bit more movement. And then finally, the gas, there's a lot of empty space between the particles, and they'll have the maximum amount of freedom of movement. So this first beaker is going to be our solid, right? Because the particles are packed really tight. The second beaker is going to be our liquid because they've got a little bit more freedom. They're not packed as uniformly. And then finally, our last beaker will represent the gas. All right. So which of these three states of matter do we think is the most dense? Well, remember, the amount of matter in a particular space is what defines density. So the more matter that you have in a small space is going to be a more dense sample than having the same amount of matter but in a much larger space. All right, so our solid is going to be the most dense state of matter. Now, not always true. Water is one exception, but for the most part, if you have a substance, a chemical substance, its solid should be more dense than its liquid state, and its liquid state should be more dense than its gaseous state. All right, so the reason for this, why did we choose the solid state? All right, because we have the same amount of matter. Oops, oops, sorry. Matter packed into a smaller volume. All right, so as that volume decreases, the density is going to increase. All right, as the mass increases, the density also is going to increase. And we're going to see in a few minutes when we look at the formula for density. All right, that's going to be how the variables are related to one another. Now, is density a chemical or physical property of matter? It is a physical property. All right, it is dependent on the state of that matter. So the density of a substance will be different in its solid versus its liquid versus its gaseous phase. But it is a physical property. It doesn't matter how much of that substance you have, its density will always be the same as long as the state of matter does not change. All right, so the types of forces that are going to influence a substance density, because it is physical property, then we're talking about our with the ER, molecular forces, those forces between the particles. All right, so generally speaking, as these IMFs increase in strength, the density also will increase. All right, and that makes sense. If they have strong intermolecular forces, that means the particles are closely packed together, which makes something more dense. You're going to have more particles in a smaller volume because they're all attracted to each other. All right. How can you change a substance's density without changing its chemical identity? Well, that is that state of matter idea. So if you change the state of matter, then the density will also change. All right. All right. So basically, if you go from a solid to a liquid, you're going to get different density values. If you go from a liquid to a gas, you're going to get different density values. And generally, all right, the density of a solid will be greater than the density of the liquid, which will be greater than the density of the gas. All right. But like I said, there are exceptions to this rule, and one of those is water. All right. So, how do we know about that exception? Well, we can estimate the density of objects, not put a numerical value on it, but comparatively estimate by running a very simple experiment. All right. So, here I have the following substances: cork, water, oil, stopper, and rock. All right. How can I estimate the density of these different substances? Use the graduated cylinder right to show where all the substances reside when placed in the cylinder. Then list the objects in order of increasing density. All right. So anytime you want to determine whether two liquids, whether one is more dense than the other, one way to do that is to pour them on top of each other and see which one floats and which one sinks. Now, for our purposes, we're going to be looking at oil and water. So if I take some water, all right, and pour it into my graduated cylinder, let's do about here. Oops, you know what? Let's use this. All right. And then I take some oil. I should see them layer on top of each other, just like this. All right. They aren't miscible. So in other words, they won't blend. So I'm going to see one layer on top of the other. So at the very least, I know that the water is more dense than the oil because it sits on the bottom of my graduated cylinder. If I now drop in my objects, I'll start with the rock. All right. As I drop that rock in, it's going to go through the oil, through the water, and then it's going to sit down on the bottom of my beaker. All right. So this is my rock. All right. Let me label my, whoops. And this is the water. And then this is the oil. All right, if I now take the rubber stopper and I drop it in, it's going to sink through the oil, but sit on top of the water. So my stopper will sit here. All right, and what that tells me is that my stopper is, whoops, that my stopper is more dense than the oil, but less dense than the water. All right, then I'm going to end by dropping in my cork. And what I'm going to find is that my cork is going to sit here on top of the oil. All right. So what we can do is look at this and we start at the very bottom. That is going to be the substance with the highest density value. And we end at the top, which will be the substance with the least density. All right. So order of increasing density, the density of the cork is going to be less than the density of the oil, which is going to be less than the density of the stopper, which will be less than the density of the water, which will be less than the density of the rock. So the rock will be the most dense, the cork will be the least. All right, this experimental method is called the sink or swim method. And if a substance sinks, all right, it has a greater density than the substance it sinks through. If a substance floats, it has a less density than the substance that it floats on. All right, now this doesn't work for everything. All right, it works best if you have a liquid and you know what that density is, because then you can say, all right, well, then the density of this object must be greater than that value or less than this value. All right, it only works for liquids and liquids if they don't mix together. If they mix and form a homogeneous mixture, then you can't tell, so it's not going to work. But for our purposes, it's a good qualitative way to look at density. All right. Now, we don't want to just look at the the qualitative aspect. We also need to be able to calculate this value. All right. So we're going to start by writing the formula. All right. So just in general, density equals mass divided by volume. So that's the formula. All right. The density is the amount of matter in a particular space. So the mass divided by the volume. So for variable symbols, we use D for density, lowercase m for mass, and a capital V for volume. All right. So we should be able to use this formula to solve for any of these three variables. Now, we don't always work with, well, sometimes we work with formulas. We don't have as many as you will if you get to physics. But density formulas, I mean, sorry, formula triangles can be very handy for this type of stuff. All right. So density, mass, volume. All right. So density equals mass divided by volume. All right. The volume equals mass divided by density. And then the mass equals density times volume. So you can use the formula triangle to pull out all three of those formulas. But you can also just use algebra and manipulate the formula as is. I'm going to leave that up to you. Everybody solves problems a little bit differently, so it's going to kind of be you figuring out your best method. All right. However, when we work with formula-based problems, all right, you need to have a variable list and you need to write out the formula before completing the problem. All right. I look for that for all problem solving. You have to show me that you understand what the variables are, and then you have to tell me what formula you are planning to use. If you skip those two steps, you do not get full credit. All right. By the same token, if you keep those two steps in and then miss something in calculating, you get points for putting those two things together. So let's make sure that we're listing our variables and then writing the formula we're going to use. All right, so we're going to solve a couple different problems using our density formula. What is the density of a piece of metal with a volume of 60 milliliters and a mass of 350 grams? All right, so I have a volume value of 60 milliliters, and I have a mass value of 350 grams. And the problem asks me for the density of this substance. So there's my variable list. Up next, my formula, density is equal to mass divided by volume. And now I'm going to plug in what I've been given. So 350 grams divided by 60 milliliters gives me a density of 5.83. Now, the unit here looks a little strange. It's a compound unit. It's grams divided by milliliters. All right, so this unit is called a compound unit. All right. You have to have both pieces. Don't just write grams. Don't just put milliliters. It's grams per milliliter. All right. That's what a density unit is going to look like, a mass divided by a volume unit. All right. Up next, gold has a density of 19.30 grams per milliliter. If you have a sample of gold with a mass of 25.2 kilograms, what is the volume of your sample? All right. So we're given the density, 19.30 grams per milliliter. All right, we're given a mass value of 25.2 kilograms, and we're asked to find the volume of our object. All right, now, one positive about putting the variable list in there, because I know students don't love to do it, is you can catch things like this. All right, we have grams in our density unit, but kilograms in our mass unit. So they have to match. All right, so these two units must match. All right, which means I need to convert one of them. Now, I don't like to mess around with compound units. I think it's a little confusing. So instead, I'm going to convert my 25.2 kilograms. Now, remember, when you go kilograms to grams, you need to move the decimal 3 spots to the right. So the number is going to get bigger. So 2, 5, and then 200 is going to be that number in grams. All right. So if you need a little help with your metric prefixes, just remember, go back, check that screencast, or just let me know. All right. So next up, my formula, density is equal to mass divided by volume. All right. So I can plug my numbers in, 19.30 grams per milliliter equals 25200 grams divided by my unknown volume. All right, so I'm going to need to multiply the volume to both sides to get it out of its denominator. All right, so 19.3 grams per milliliter times the volume equals 25200 grams. And then I'll divide both sides by 19.3, and I end up with a volume value of 1,306 milliliters. All right, so that's how we use the formula to go from density and mass to volume. All right. For number 3, solid sodium chloride has a density of 2.17 grams per centimeter cubed. What is the mass of a sample of NaCl with a volume of 355 centimeters cubed? All right, so we have a density value of 2.17 grams per centimeter cubed. We have a volume value of 355 centimeters cubed, and we're asked to find the mass of our substance. All right. We check our units. We have centimeters cubed for the volume, and that is also in our density. So we don't need to do anything there. We're just going to set up the problem. So we write out our formula. Density is mass over volume, and we have 2.17 grams per centimeter cubed equals an unknown mass divided by 355 centimeters cubed. All right, so we're going to multiply both sides by 355. So we have 2.17 grams per centimeter cubed times 355 centimeters cubed equals the mass of our object. All right, so we plug that into our calculator and we find that we have a substance with a mass of 770 grams. Okay. All right, up next, determine the density of a rectangular piece of concrete that measures 5.02 centimeters by 2.1 centimeters by 5.8 centimeters and has a mass of 43.8 grams. All right, so we have a mass of 43.8 grams. Now, we've been given the dimensions of this rectangular piece of concrete. So we're going to use those dimensions to calculate the volume of that object. So remember, the volume of an object that's regularly shaped in a rectangular shape is going to be length times height times width. So we're going to multiply these together. All right, so that volume will be the length times the height times the width. And in this case, that's going to be 5.02 centimeters times 2.1 centimeters times 5.8 centimeters, which is going to equal 61.1. Now those centimeters get multiplied together too. So it's a centimeter times a centimeter times a centimeter, or centimeters cubed. All right, so this is going to be our volume value. We have our mass, so we can calculate our density. Density is mass over volume. So 43.8 grams divided by 61.1 centimeters cubed. And we find that this substance has a density of 0.72 grams per centimeter cubed. Okay. All right. So if you have a regularly shaped object and you have a formula for volume, you can calculate the volume of anything. But a lot of the times, the object we're trying to determine the density of doesn't have a regular shape. So you can't just use a formula like length times width times height, like we just did. All right. If you have an irregularly shaped object, you're going to have to use some other method to determine that volume. And the best method to do that is called volume by displacement. All right. So here I have two graduated cylinders. All right. I have an irregularly shaped object and I need to know its volume. So I'm going to take that object and drop it into my graduated cylinder. The volume of that object is going to change because the water gets pushed out of the way by the object going into the water. This is called volume by displacement. All right. We can measure that change in volume of the water, and that is going to equal the object of the cylinder. So you need a cylinder like this. And that change in volume is going to be equal to the volume of your object, which is equal to the final volume reading minus the initial volume reading. So you'll have to read the cylinder before you put the object in and then read it again after the object is in. And that difference is going to be the volume of this object. This works for any object as long as it will fit into your graduated cylinder. All right. Make sure you don't put something in a graduated cylinder that you can't get back out. That's not a good idea. But we have all kinds of sizes of graduated cylinders, so we should be able to find one that will work. All right. So let's do a problem with this method. So when the zinc piece is placed in the graduated cylinder with an initial water level of 35.5, that level rises to 45 milliliters. Find the density of our zinc blob. Well, up above, it tells us that the mass of this blob is 63.83. So what we have is a mass, 67.83 grams. We have an initial graduated cylinder reading of 35.5 milliliters, and then we have a final graduated cylinder reading of 45 milliliters. And we're asked to find the density of our object. All right, well, the first thing we have to do is calculate the volume of our object, which is going to be equal to the final reading minus the initial reading. So 45.0 minus 35.5 gives us a volume for the object of 9.5 milliliters. All right, now that we know that volume, we can calculate density using the density formula, mass divided by volume. All right, so we have 67. Why do I keep doing that? 83 grams divided by 9.5 milliliters gives us a density of 7.14 grams per milliliter. Okay, so again, we can determine the volume in several different ways. If it's a regularly shaped object and we know the formula for that object shape, then we can use that. We can make a measurement of the lengths of the sides and use that formula for a square or rectangular object. If it's irregularly shaped, like a cylinder of zinc, like this one, or maybe a rock, or basically anything that doesn't have a shape that we can measure, then you can use a graduated cylinder and this idea of volume by displacement. Okay. Regardless, the density formula is the same for all these problems. It just depends on what your unknown is. All right. If you have any questions, please don't hesitate to ask.